Welcome to this week's Swarf and Chips. We're here at 76 Project. Now, this is a 5-year-old company based in Peterborough. Today's show, we're going to cover exactly what it is that they're making. So if you're into bikes or you're a cyclist, then make sure you're watching the show. But they have recently invested in a HP multi-jet fusion 3D printing machine. So we're going to find out the process, have a little tour of the facility and find out what this pig has got to do with it all. One little piggy went to market, one ended up underneath my arm, and the other ended up on your bike. Why is this wrong?
Well, we had to think of a name for the product.
It's a great name.
This is Piggy on bike storage, so Piggy because it piggybacks on. The idea behind it was an alternative way of carrying tools and spares on your bike. So traditionally people would use a saddle bag, which might be a bit rattly and catches on your tights
Trousers
or
and
shorts,
yeah.
Or they might put it in their back pocket and have a bulging jersey. So instead we've made this platform and strap and bag that positions your stuff underneath your bottle cage. It's a standard bottle cage that mounts to the platform, and you undo the strap and you can then get access to the bag, which then can have all your tools in it.
Puncture
inner
repairs,
tools,
essentials,
tubeless, multi-tool, all the stuff you need if you have a regular kind of maintenance issue whilst you're out and about. These themselves, we've tried to keep everything made in the UK wherever possible.
Yes.
So we get the platform is injection molded for us in Leicestershire. In Yorkshire, the straps are made by a company who actually normally does dog leads.
Oh wow,
yeah,
that's interesting.
So, yeah.
But
so,
you know what, with all of the work that you're producing with the 3D printing and everything, are you finding you're able to bring back work to the UK? Is that a benefit to you? Will that help you with your business going forward?
Yeah, I mean, look, we're not against getting stuff done in the Far East. These bags were done in the Far East, for instance, but as much as we can do locally, the more control we can have. We don't have to buy in huge quantities. It just helps the flexibility in what we want to do as a business.
And you export a lot as well, so there's such a huge... there are very few countries that you don't sell to. This is amazing.
Yeah, I mean, 45% of our products are exported. I mean, the US is our biggest market, but we pretty much, Azerbaijan, for instance, we had a few orders from there, anywhere that people can buy from our website from.
So this is one of the finished 3D printed parts. So I wanted to take you on a little bit of a tour around their print lab facility so you can see some of the investments that they've made and how they're making these parts. Now, this is from Matsuura. This is a HP multi-jet printer, but how does it all work, Rob?
Okay, so the multi-jet fusion printer, it's a powder bed based process where nylon powder is laid down onto this bed and it's laid down, then this print head comes across and lays down a fusing agent, and the fusing agent, basically wherever the fusing agent is, the powder will melt to a high enough temperature to become the product. What we have here is some heating lamps and additional ones over there, and this passes over I think about 1800 times in a full build, and every time it passes over it will lay down the black until you've got a 3D, lots and lots of 3D parts in there in the finished build. So
I've just shown the audience this, but it doesn't look like that yet when it comes out
not
from
at all.
here.
No.
So you have a block, is that correct?
Yeah, so in here is the build unit. The build unit itself is like a cart and it's filled with the powder that you use, and you use this between two stations. So when this is printed, you pull it out and you will transfer it across to the processing station.
What's quite exciting about this though is the fact that you're processing within this build unit. You can design different angles, different levels, different sizes of parts all in one go, so you can just leave it to run overnight and it's prints.
That's right. I mean, we often run over the weekend. Come Friday afternoon, there's a bit of a rush to get everything set up, and we'll leave it running by Monday morning, which was this morning. That the build will come out of the printer and we'll wheel it across and push the cart in, and we'll be ready then to unpack the parts. To unpack the parts, you vacuum up all the loose powder,
Yes.
and then you can also rub the parts to get off any additional powder, and then the parts get put to the side, and then they'll go off to be processed elsewhere.
Okay, and let's see the next process.
Okay, so the next process, we surface our parts using this Dimension PowerShot S.
So it's gone from white, and you've had
That's
to
right.
get rid of the powder and dye it first.
Yes, yes.
And then it goes into here.
That's correct, yes. So this machine is basically a shot peening machine for plastic parts. So my shot peening is normally for metal, this one's for plastic. It's an automated machine, so we put the parts into this, what looks like a washing machine drum.
It does, yeah.
We close the door, and then this drum goes round slowly. As it goes round slowly, we've got two nozzles here which blast millions and millions of plastic beads at the part, and as it blasts the part, the surface becomes more homogeneous, and it gives a lovely sort of satin sheen to it. And then we have other nozzles that clean off the powder when it's not needed, and at the end basically you come out and you've got finished parts, and all in all it only takes 15 minutes to do a whole machine worth of stuff.
But before all of this, you didn't get the right finish. It wasn't kind of consumer ready. But now when it goes into here, it's consumer ready. It's ready to go.
That's right. I mean, for several years we used another process, which was vibro polishing, and it's okay, but the quality is just not the same end quality consumer part. It was also, those parts also absorbed water, and they didn't have crisp edges. So this just gives us the final end part that we really need if we're doing consumer products.
We've got here an aerodynamic cycling helmet. Now, Paul, you've had some highs and lows with this project. Tell us what it's all about, and maybe what you've had to go through to achieve what you've got today.
Right, yeah, so we've been working with a company called Drag20, who are aerodynamicists.
Okay.
So they came to us wanting to reproduce part of the helmet, which gives the rider a large aerodynamic advantage. So as this helmet normally comes with its own helmet tail,
Yes.
this suits the majority of riders and is fantastic.
So say 99.9% of riders.
Yeah, a lot of
that works.
riders, but there's that kind of final 1% of professional triathletes, professional cyclists that want to have that extra aerodynamic advantage.
Okay, so over 100 miles, that's a minute.
Yeah, so in an Ironman triathlon, it's a huge advantage.
Yes.
So we're been tasked to try and produce this helmet tail. So the data and the shape has all been calculated by Simon at Drag20. So it's been optimized for a certain shape. But what we want to be doing is producing, say, 5 or 10 different shapes, which suits a particular rider. So when the rider's in position, it will have that advantage specifically for them. So we're not talking about having a totally bespoke helmet tail, which is what we can do, but it's not totally fitting with what we're trying to do within trying to sell these in the future. So the original helmet tail comes with the helmet, but this is traditionally injection molded, and the tooling in that is somewhere along the lines of sort of 50, 60,000 pounds.
Great. So if you're into your cycling and you go over a long period of time, you could be saving seconds of your time with one of these. We have here the AS slider. You're going to have to explain to everybody what that means.
Okay, Lindsay, the AS slider stands for the anti-strap system. And as it says on the tin, there is no straps on this bag. So traditionally this type of bag, top tube bag, would have to be strapped to the bike. So you'd get a strap around the front and a strap around the frame, which would rub on the frame, and you'd have to take it all off. So what we've done is we've created special brackets, so you can pull the bag.
There we go.
So you can pull the bag, these 3D printed brackets. So we have the bag made for us as well, and then these integrate into the bag. We have a slider, which is the piece in the middle, and then at the front there's a clip. So you use quick release, and we put it back, and it just clips onto the front. And what happens with that is it stabilizes on the top tube, and we also means that when you turn the bars, the
It's not
actual
affecting
bag
it.
doesn't move at all, which is a real issue with the current designs.
Can I just let you know, my boss needs one of these because he sent me a photograph of himself sitting in a field the other day because he had a puncture and he didn't have a puncture repair kit. So Paul Jones, this is one for you. You certainly need an ass slider. If you're a fan of the Olympics, then this product is definitely one for you. Explain what this is, please, Paul.
So it's an aerodynamic handlebar, specifically designed to work for triathletes. So this is actually being used by Jonathan Brownlee this summer in the Olympics.
Congratulations.
Thank you very much. Yeah, it's really exciting for us. So this is actually a product being designed by Drag20, based in Silverstone, who again are aerodynamic specialists.
But they've got a facility, haven't they, like a wind tunnel?
Yeah, so they have access to a wind tunnel where they're able to fully test these products, and they have many years of experience behind them. We're really lucky to work with them on several things, and this is probably the most exciting thing we've worked on with them.
Yeah, and so you've won this. This is very exciting. But what things have you got to consider from a manufacturing perspective? Because there's lattice work within here as well. You can only really do that 3D printing.
Yeah, it's only so lattice work within the Materialise Magic software that we've used is able to shell the part completely and lay a lattice inside that to maintain its stiffness but keep the weight down. And that particular process can only really be achieved in additive manufacturing.
So when someone's cycling, forgive me, I hope I'm correct, they're leaning forward here and it's kind of bespoke to the rider.
It can be completely bespoke to the rider, and we've made this bespoke to the handlebars that that particular athlete's using. And, and for these handlebars, we haven't to produce a small quantity to go to all the British triathletes. And they use different bikes, so we're kind of making it a little bit bespoke for each of the riders.
Yes.
But yeah, that's what we've been doing.
Thanks for watching this week's show, and great to hear 76 projects doing so well and expanding their business by investing in such equipment. Hopefully you're going to see and have one of these consumer products on your bike soon. I know our boss Paul definitely needs one because I don't want to get any more pictures of him being in a field without his puncture repair kit. So thanks for watching the show, and we'll see you again next week. Oink, oink.